Hello, welcome back to class. This is the fifth module in this course, and this module focuses on incident response. I hope you've taken time to go through the last 4 modules, where we have covered several aspects of this course. So after this fifth module, we have one more module. That will be module 6, and then we'll wrap up the course. For the learning objectives, at the end of this lesson, at the end of this module, you should be able to understand incident detection and analysis, and also perform some experiments around that. Look at log aggregation and correlation, create alert and monitoring systems, and then also look at response procedure developments. So we'll begin with Elastic Stack configuration. This script here is a snippet that shows YAML file for the Elasticsearch setup. This YAML file is actually from a Docker Compose. So we look at the file between lines 650 and 60, we see something that looks like what we see here. So we see the Elasticsearch being instantiated with an image name, and then container name, and then the environment. The environment you're using is a single node environment. And then the volume will be created. There might be several volumes, but for this experiment, only one volume is important, is used. And then the port of interest is port 9200. We saw that in labs 2 and 3. And then there could be several networks that can be created for a particular container, but for this project, for this lab, it is only one network, which is secure band network. Also looking at the Elasticsearch setup, there could be some configuration details. For this lab, I've said already, is a single node environment, single node deployment for the environment, and then the heap size of the RAM given is 512 megabytes, which is suitable for whatever experiment we have to run in this lab. Of course, it is scalable. It can increase, scale up, or scale down. And then we also have persistent storage that can be accessed via the Docker volume. And then for you to access the container, just copy this URL, http localhost port 9200 to URL, and then you should be able to access the machine. Just make sure that the machines are all running like we did in labs 1, 2, 3, 4. Is the last 4 labs. The log stash passing rules. There are several rules that help us to pass the log that are the logs that are being collected or being captured into the log file. So this is an example of the configuration passing rule, where we have the inputs being instantiated, and the input you have some contents, some arguments in the file. Then in the file, you specify the path. In that case, it is log/securebank.log. And then we have the starting position where we are saying let it be beginning, and then we have the path, that is the 6dB path. Looking at Kibana dashboard creation, Kibana, like I said in labs 3 and 4, is actually used for visualization. So whatever the log has, the log file has, whatever log has been collected, we can visualize that using Kibana. So Kibana gives us the privilege to view that. We'll see how that looks like, and I've provided some code snippets that enable you to run to see or visualize what we have. So this is sample Kibana dashboard configuration file for the incident response experiment, which we are working on. Then for the data ingestion pipeline, there are 6 steps that we use for the data flow. So step 1 is where you have the application logs. and the application log is actually stored in the evidence directory, and the name of the file is securebank.log. Then the second layer is the host copy, where you make a copy of the secure log into the logs directory. And that happens when the setup.sh file is executed, like we did in some labs back. And then step 3, we have the log stash input, which also shows the log file stored in the logs folder or the log directory. Then 4, we have the log stash processing, where grok parsing is performed, pattern matching is also performed alongside tagging and some other experiments. Then 5, we have Elasticsearch output. The output format will usually include the timestamp, particularly the year of the creation of the log, the month, and the day. And then 6, finally, is with the Kibana visualization platform that enables us to view what we have logged or what we have monitored by either looking at the alert created on the dashboard or thereabouts. Continuing with the data ingestion pipeline, looking at the setup.sh file between lines 35 to 38, we have some codes that look like what we have here. We have for generating initial logs of the core, the first command, which is called ss up to, we have def/null does generate initial logs. So the same thing applies to the second command. Now, difference is that the second command has a default password and username. In this case, the default username is test, and the default password is test. Then we have a command that copies the log to Elasticsearch. That is the command we have, which is copy. Let me get my pen so I can navigate with that. So this is a command. This command, what it does is to make a copy of what has been collected as a log. Looking at the log analysis and correlation, so this slide shows the patterns for different attacks that we've talked about. In the previous labs, we looked at a few number of web attacks, like SQL injection, like command injection, like cross-site scripting, and then the debug mode and one other command type. So here we have some lines of code that help us to identify the patterns, okay, in the code. So the first part of this, that get the pen again. Yeah, the first part here is for SQL injection, and then the second part is for command injection. The third part is for cross-site scripting. Let me erase this. So we have a table here. This table is a table that we use for timeline reconstruction. What this does for us is to provide us with a table that shows the time stamp for the container, the event type, whether the event was a login attempt, a login success, login view, login failure, login or transfer attempt. And then it also shows the source IP. The source IP is the IP address of the container or the computer where the attacker is shooting from, or in this case, where you are doing the spelling from. That could be the IP address of the Kali machine. And when details show the payloads that have been executed, so we see some payloads listed there. All right. And then it is also possible to manually identify the source IP address. So this line of code is a snippet that helps you to look at how to identify the source IP. the IP of the attacking machine, for instance. Then looking at user behavior analytics, it is also possible to manually identify the behavior or to analyze the behavior of the attacker once you know how each attacker or each attack behaves. And the first thing to do is for us to capture the baseline of the machine. The baseline of the machine is the normal working state before perturbation, before disturbance, before injection, before attack. So we need to capture that, and then if there is any variation from that state of the machine, then one can say that there could be some suspicious attempts. All right. So for the baseline behavior analysis, let me get my pen again. So, for instance, the login IP address, the login IP address range, the regular pattern, viewing patterns, account viewing pattern, typical transaction amount, these are baseline behaviors of the system or of the user. And then for normalized behavior, when you see a thing like multiple SQL injection pattern in usernames, for instance, you find command injection account ID parameter, you find unusual transaction amount, or you find rapid sequence of authentication events. These are what we may call indicators of compromise. So either the system has been compromised or there are attempts to compromise the system. So in that case, we have anomalous behavior. Let me get this out. So this continues the user behavior analytics. If you detect multiple failed login attempts from the IP, then you can suspect something. Flag successful logins with SQL injection patterns, alert to monitor, and many other things. These are anomalous behaviors of the users in the system. So looking at alerting and monitoring part of the module, I just say, and it's important for you to understand that for us to visualize what the log has, we need Kibana. And we need to actually create Kibana alert rules that can raise triggers if anything happens to the system, where there's a difference from if the system behaves differently from the baseline. So this line of what we see here, this line of code we see here is a snippet that shows us how to create the Kibana rule. But I'm going to show you, I have this, like I've been doing it, the script you see here that helps you to create your own Kubernetes rules the way you want to see. And then you can also set threshold. Thresholds are the values that is set to say if this number is exceeded, then do something or confirm something or suspect something. So these are thresholds. For instance, where you have failed login, you can actually set up failed login thresholds to say if a user tries to log in, say, then get the brand. Okay, say if a user tries to log in 5 times and all the 5 times fail, then suspect. Okay, so that is where you can actually define that. Then we also have command injection frequency alert that can be corrected. In this case, we are setting it to 1. Okay, so if the frequency is more than 1, then you can actually suspect something. We can say a message like critical command injection attempts detected once the frequency is exceeded. So anomaly detection, okay, we've been talking about that. These are things we do as a way of responding to incidents that happen. So here we have a number of steps that show us how to detect anomalies. For instance, we can actually implement anomaly detection rules. I've talked about the use of baselines. I've talked about, okay, so one here is, let me get my pen. So we have number one, a baseline, where you set your baseline to a number of login attempts per second or per hour. Then we also have alerts if logins pass particular, where you have to define an IP address to say, for instance, you have your IP pool. So if you find any IP address coming to the network which is not in the pool, then you can actually suspect. Then you also have number 2, you have transaction amount anomaly, because we're dealing with the banking application. So if a user tries to withdraw or transfer or do whatever transaction beyond a particular amount of money, then they can raise an alarm. Then we have time of the day. If the baseline is that users go to bank to do the operations between 9 to 5 p.m. So if you find unusual activity, say at about 2 a.m., then you can raise, the system should raise an alarm. Okay. And then we also have local IP ranges. Okay, I've talked about IP address. So one that is not, the IP is find the network is not in the range, and then you can suspect something on the network. So those are some of the things we do to create our anomaly detection rules or alert on the system. For real-time monitoring setup, again, a number of steps have been provided here for us to look at. So for the monitoring architecture, what we talk about, what we mean by the monitoring architecture, where you put up a structure to provide monitoring for the system, either by creating alerts or looking at the logs or visualizing or manually, automatically. So we have, first of all, we have to collect data. We call it data collection. And then the second thing is to process what has been collected. That's the processing pipeline. Your data or your log has gone into the log file or the log directory. So at that point, it needs to be processed. That is in step 2. In step 3 is where you have created your alert. So if in the course of processing the data, what you find is different from the baseline, then alert should be created. And then fourthly is to visualize. This visualization can be in real time. So as things are happening on your network or on your application, and the logs are going in, then you are visualizing in real time. Looking at incident response plan, it is important that incident responders have a plan and also have incident response playbook where you document what actions should be taken should any of these things happen. And of course, you have plans on how to respond to incidents that happen to your system. So one of the things is to have a detection procedure in place or procedures in place. So I've talked about the fact that detection can be automatic, it can be manual. So you have automated detection, you have manual detection, you have escalation matrix, and then thirdly, you have to perform your initial assessment where you confirm if the incident is genuine or maybe you're having a case of false positive on your network. Then you determine what scope that covers and what impact that brings to your system, or your application, or your network. And then, of course, you have to classify your incident types. Okay. Containment strategies. These are things that can be done or should be done should anything happen to get back your system to working state. These are incident, what we call a recovery plan. Or recovery strategies. Okay, how to deal with, how to manage your risk at this time. Are you going to avoid the risk? Are you going to mitigate the risk? Are you going to transfer the risk? Or are you going to minimize the risk? Cool. And of course, that's depending on the kind of attack that comes into your log or you find on your dashboard, that determines what your containment strategy would be. For instance, the first step, the first part here, the first part is for SQL injection attack. We have immediate actions and we have technical containment. For immediate action, of course, it is important to temporarily disable affected login endpoints, block your attacking IP address at the network layer. And then technical containment, you have to implement your web application firewall rules to block escalation patterns. And then the second part is SQL injection. Can I get my pen? Yes, this is SQL injection. In SQL injection, the immediate action is to disable command injection execution functionality, block attacking IP container, IP address, review and kill suspicious processes. And then typical containment implements command whitelisting, and then add input validation and sanitization, increase process monitoring. For cross-site scripting attack, the immediate action is to sanitize affected user input. And then other ones follow. Then for technical containment, implement content security policy, CSP, add your cross-site scripting protection headers and deploy client-side protection to your network. For eradication steps, the root cause analysis is important, where you have to establish what is causing the problem on the network or on the system. How is the attack being implemented? How is it coming? What are the attack surfaces? So you need to find out the root causes. That is what we call that's what we call the root cause analysis. That can happen by you reviewing the application source code for vulnerabilities. We saw in the previous lab that the application that we are dealing with has some lines of code that are vulnerable. So we can manually review that and then analyze attack vectors and entry points, identify security gaps, and misconfigurations. Then in step two, you have to now apply vulnerability remediation by applying code fixes, which we did in the previous lab. And then step three, system cleaning, remove suspicious files and backdoors, we set compromised credentials, clean affected databases, and then for validation. At this point, you are testing your fixes, okay, in the station environment, not in the production environment. You verify that your weaknesses have been eliminated, and then conduct security retesting to see if the bugs have not been removed. Then for recovery procedures, we have system restoration. This time around, you're bringing the system back to life. That can include you going back to your clean backups and then bringing back whatever thing you need to do. And when you have service restoration, at this time you gradually restore services to its functional state. Then there should be business recovery plan. At this time, you are communicating to your stakeholders what you've done, what happened, what, and then of course you have to log. There is also what we call lessons learned. Where you document what you've learned in the process so that should any of this happen again in the future, whether you are available or not, then actions can be taken. And then we have the post-incident activity. We have talked about lesson learned, and then update to incident response playbook, and then you move on. So findings of all of that. Your incident response depends on the level of skills you have and the tools you are using. All of these are embedded in your capabilities. Capabilities involved your skill, the skill sets of your team, and of course, the tools you're using to do what you are doing. So we have the current detection capabilities. For instance, real-time log ingestion and passing has to be in place. Pattern-based attack detection has to be implemented. Basic threshold-based alerting has to be done. And then centralized log correlation has to be done. Okay. So once that is done, and you complete the manual, you complete the model, you're going to say that you implemented those first four. Then you also say that clustered attempt logging may have been done or may not have been done. So in your reporting, you report what has been done and what has not been done. So you see the ones with tick green shows what may have been done, and the ones with X crosses show what may not have been done. Furthermore, for coverage assessments, once you've completed all the steps in the script, which I'm going to show shortly, you will discover that vascular injection detection have been completed by 85%. Command injection, 90%. Class of scripting, you see that no locking will be done. By the time you look at the law, we say that it has not been done. And with authentication anomalies, you see that 70% of that has been achieved. Looking at the response time metrics, there are several metrics we use to measure our response time. First of all, we have the incident response time. So detection time should usually be less than 1 second. That is what is going to make it real time, because as long as anything happens on a network, the lock should be dropped and then should be visualized. So typically less than 1 second is good enough. Alert duration, 5 seconds, that is a Kibana. When you're setting up your Kibana alert rule, give it less than 5 seconds. Initial response can be manual. This depends on your monitoring schedule. And then containment time can be in minutes or can also be in hours. So for measured metrics, we have a mean time to detect, which should typically be around 5 seconds. The mean time to respond should be typically 15 minutes by estimate. And the mean time to containment, 20 minutes, mean time to recover, 2 hours. And then, of course, your improvement opportunities where you need to make changes. So it is important for you to reduce your mean time to respond and then improve your mean time to detect with either additional mechanisms or whatever thing you need to do to improve it, and then streamline your recovery process. Alert effectiveness. So when you create your alerts, you're going to see whether the alert, whatever the alert does. So of course, you create alerts for skill injection attempts, you create alert for command injection attempts, you create alert for cluster scripting attempts, and whatever attack we are looking at. And for every attack attempt, or for every alert you create, you're going to have the classification for the severity. You're going to have information provided. You're going to also look at the actions that can be taken for that. So that's for all of them. So for improvement combinations we talked about earlier on, this depends, of course, again, on the kind of attacks we are seeing. So we have immediate improvements plan, we have short term. So if what you need to do requires the actions within 24 hours, then that's immediate improvement plan. If it's going to take about 7 days, then you're talking about short term improvement. If it's going to take about 30 days, then that is medium term. If it's going to be about 90 days or more, then we're looking at long-term improvement plan. Okay. So compliance alignments. Because the application we're dealing with has standardization, it's supposed to have standardization for the PCI DSS because it's a payment card implementation solution that we're dealing with. And this is supposed to come with a number of requirements. For instance, requirement 10 of that regulation provides track and monitoring for all accesses. So we're going to report whether that has been met by the time we're done with the lab or it is partially met. The same with requirement 11, which is for regularly checking testings of security systems, and then 12 for maintaining security policies. And then also, I've talked about in the previous lab that we are dealing with the frameworks we are dealing with are the NIST cybersecurity framework and also the ISO 27001 controls. These are things we need to see by the time you complete with the lab whether the provisions of this frameworks have been met or otherwise. So vice it. So we'll go to the script and see one or two experiments we can do, and then you go through everything yourself and complete the model. So let's go to the script. The lab environment is not different from what you use from Lab1. We have your secure bound application, we have Elasticsearch, you have your Logstash, Kibana, and Attack simulation. So let's look at step one, which is Elasticsearch configuration. In this step, you are expected to verify whether or not your Elasticsearch machine is running. And then if it is running, generate initial logs, confirm verify data flow or the data flows from the application to Kibana. Okay, so we can take a look at that. So the first thing for us to do, we are only familiar with this, is to change the directory to our project. So I'm going to copy this command and then go to Kali. Okay, so I'm just going to log into the Kali machine. The login is successful. Let me increase this a little. That's rather too small. Let me go for that. 250 should be fine. Okay. So I open my terminal, log in. Okay, so I'm going to paste what I copied, paste clipboard, and then I'm into the project right now. Back to the scripts. So the other thing for us, so the next thing is for us to start all services with Docker Compose by running this command. We've done this a number of times, so paste clipboard. All right, so it has started. Let's confirm if everything is running. Yes, I can see that my machines are running. So that's okay. Back to the script. So we can run this command, which does the same thing as this for us by checking the states of the container. So the next thing is for us to check the health of the Elasticsearch by running this command. Let's check whether our Kibana is doing fine. Oh, that didn't copy. Okay, so can we just go back and copy what happened there? Oh, instead of copying, I replaced something. So go back to the machine, back to the column machine, paste clipboard. Yes, it's a failure, connection failure. So we can troubleshoot this. Let's see what happens again. Okay, it's fine. We can see that our machine is fine, you say visit files for Kibana is doing well. All right, so let's go back to the script. So we need, at this point, we need to run the set of commands. First of all, you need to enable permissions before we execute it. Copy this, paste this. Okay, we've enabled permissions, so this time around we can execute it. Just call setup.hh. Okay, so it's creating, it's performing the action that we have been configured in the script to perform for us. So this is going to take a few minutes of thereabout. So while this is going on, because it's going to take some time, let's just explain some other things on the scripts. So once this is what we're running now, so once this is up, then we'll move on to perform these actions. So what this does for us, what these lines of code, the 3 lines of code do is that one, it's going to make a test with our HTTP request to generate initial logs, and then it's going to copy the logs from the application container to this directory. So what it means is that once this is completed, we are to run these 3 commands. Just run them two commands rather. The first one is this, and the second one is this, which I explained in the slides. So let's see whether we are good to go. Oh, it's still running, so we'll leave it there. We'll leave it there. So you just take your time to see how that works. So once that is done, then we'll move to step 2. Step 2 is where you verify your Elasticsearch data injection. So whether the initial logs from what you've done here have been created. So if the logs have been created, then you can check the index of that by running this command. So, and then you can also query the initial log document by running this command. And then if you're supposed to see something in the index. So but if no index appears, you can't find index in the log, so you run this other command. So um, you can also check what is happening in the log stash by running this command, and then you check if the log directory is mounted into the log stash container by running this command, and check if the file is visible inside the log stash container by running this command. And then, of course, at this time around, you are going to, after all of these commands have been executed, you're going to have to configure your Kibana dashboard. So what you simply do is to take this URL, just open a browser, something like this, just copy this, and then go to your, this is running, go to your browser, that's your browser, and then paste it here, and then enter. So we can see that it has opened for us. So we can log in as a normal user. We can actually crack this, which we did in the previous lab. And then once you've logged in into the Kibana application, you can create your index pattern by going to manage. From manage to stack management, then you see index lifecycle management, index patterns, and then create index pattern. Okay, so when you're creating the index pattern, you see a field called pattern. So the name for that and the content for that field should be this, what you see here. And then time field, you put this command, and then you just click create pattern command. Now, It's possible that you cannot find the name, the button create index pattern. So if you can't find that, what you do is copy this entire code to your terminal and then execute. So if it works for you, then you see your ID as a field created for you. So if this happens, then you can just go straight to where you check your index container by running this command. And this time around, your count is expected to be greater than 0. So if the count value is not greater than 0, what you can do is to make a directory, okay, and then copy what is in the log to the directory you've just created, and then verify that everything is fine by running this command. And then you confirm that your log or your log container now has a content. So by running this command on the terminal, and then you can then force your log stash to read what has been copied by running this command. Everything here or this. This time around, your count is supposed to be greater than 0. But for any reason you discover that your count is still not greater than 0, so what you do is so run these commands. Yes, your terminal, that's what you should do. And your count should be greater than 0. And then step 3 is where you perform block analysis and correlation, which I talked about. But in the slides. At this point, you expected to simulate the attacks and then analyze the log generated or the logs generated. So in part A is where you simulate data. So we have the different types of attacks here. For step one of part A, we are simulating SQL attack injection. The normal login user, when you run this, it typically logs you because this one has a default username, which is admin, and a default password, which is admin. One, two, three. But the attack pattern, want to break it without logging as a normal user. you run this command on the terminal, then you should be able to access the application. All right, then this one is for the normal login for the command injection, and then the next one is the broken access for the command injection. When the third one is step 3 is where you simulate your cross-site scripting program. Where you run this command. Now, there's a warning here. SQL attempts are currently not captured in the log. So as you look at the log, you may not see this SQL injection. captured in the log. So then step 4 is where you copy your deputy logs to the elastic search by either running this command or running this commands. And up to this point, at this time around, your count is supposed to have increased. So once your count increases, you can move to part 2. If your count doesn't increase, then you can repeat the process. Okay. And then so in step 2 is where you perform analysis of attack patterns in Kibana. So here we're going to, when you log, of course, the Kibana is a web application. You're going to search for the SQL injection event. So there is a field called tag. So in the field that calls tag, you copy this and dump there and see if anything pops up to show that SQL injection attempt is one of the attack patterns. Found in the Kibana log. So note down the timestamps, the source IP address, and username. These are values that you have to note down by expanding the document to see. Now, another put here, if it says no result match your search criteria, because it's possible while you're searching for them, or you're searching for the injection attempts, what you need to do is that you can see what a raw document actually looks like by just running this command. And then B is to check if if the fields are available in the index by just taking this to your terminal and then dumping. And then step 3 is to share sample of the raw log file. So you can view the format by just running. This is going to show the first 20 heads. Okay. At this moment, around your account should have increased. So for any reason, your account is still 0. All right, so you can actually run this command to see what is broken, why your count is not decreasing, because the count value is supposed to show the number of blocks that are dropping, and of course it's supposed to increase over time. So you can run this to see what is broken, and then once you see what is broken, then the run phase to replace the broken file, or yes, broken file with the correct one. You just run entire command from cat down. So yes, and stop at this closing curly bracket. So this time around, you're supposed to see something in your log. All right. All right. So now this what you can actually run the entire script to put to add something to your log. So what this does for you is that is the end at EOF, this end of file. What this does for you is that it's going to add something to the log, and that what it adds is going to include something like SQL injection, command injection, authentication failure. All of this will be added to your log. Login attempts, log task success logins, and many of this will be added to your log. Then at this point, once that has been done, you can delete the old index, okay, by just running this command. It will delete the bad, the corrupted index in your file and allow the new one to stay. Then you restart your Logstash to pick up the new configuration file by just running this. And then this is going to wait for about 25 seconds, and then the restart will be done. Your container will be restarted. So at this point, your count should have increased. Yeah, your count should have increased. But for any reason your count hasn't increased, just run this command and then verify that everything is working fine now by running this command. If your count hasn't still increased yet, oh, that could be a serious problem. At this point in time, just copy the new file to a new running Logstash container by just running this command you see here. And then verify that the copying was successful by running this, and then reset your SysDB and then input by running this. This is going to take about 25 seconds to be completed, and then the count should have increased. If your count hasn't increased still, then just run this. Now, at any point your count is greater than 0, all of these steps will have to be skipped and then move down to the steps we're going to see shortly. Then once you run this command and you see that your count has increased, then you can go back to your search bar to look for, or the search bar to look for command injection attempts. For instance, where you see tab, just type this or copy this, and then it should show something there for you. We can also search for authentication failures, all right, by just dumping authentication failure as the input in the search bar, and that is going to find that for you. Then in part C is where we reconstruct the timeline. To do that, what you do is for you to query the Elasticsearch for a correlated timeline by just executing this command on your terminal. Just copy this and paste and then run it. Then the next is to identify the top attacking IP addresses, where the attacks coming from, which IP addresses are being used by the attackers, for instance. So to do that, for you to identify that is for you to run this command, and your terminal is going to reveal the IP addresses that are behind the attacks. So it's going to reveal the table that looks like this, what I showed us in the slide. So, but for our experiments, the only machine that we're using is a Kali machine, and this should be the IP address of the Kali machine. If your Kali machine has a different IP, that's going to be revealed to you. And then in 4, we have alert and monitoring. This has to do with the use Kibana. So at this point, we have to create Kibana alert rules to detect attacks in real time and then configure your threshold-based monitoring. So this again has several parts. So in part A is where you create the SQL injection alert rule. So you go to your Kibana, the web application, then you see manage. For manage, navigate to stack management. For stack management, go to alerts and insights, and then rules and connectors, and then you click create rule. So once you create rule, you see where you see select rule type, make sure you select Elasticsearch query. So in case it tells you additional setup required, so what you need to do is to generate a 32-character encryption key by running this command. So once you run this command, then it's going to create a 32-character encryption key. So just copy that safely and keep. So once you copy that safely and keep, run the cat command to reveal this for you. So what you're going to do is, for the script that will show for you, everywhere you see paste your 32-character key here, you're going to replace what you copied in running this code. The 32-bit character key, encryption key will be pasted here, and pasted here, and then it executes this for 5 commands at the same time. So I said here you have to replace that. That's important. And so once that is done, they copy the updated config into the Kibana container by running this command. Is going to copy that into your Kibana YAML file. So after running this, then you run this command. At this point, once that has been done, you need to restart your Kibana by just running this docker restart Kibana and then add sleep 20. So that it takes about 20 seconds for that to be done. Once that is done, reload your Kibana in your dashboard, either by refreshing whatever means you want to do, by refreshing your tab. So then you go to Oreo, you just copy this, open a new tab, copy this command and dump, and then submit. It's going to refresh the Kibana automatically for you. So it's possible that when you run this, the Kibana may fail to load. Maybe something is broken. So if anything breaks, which is what I put here, what you simply need to do is to edit your Docker Compose YAML file. So what you do is use Nano. Nano is a text editor. Run this command is going to bring up the Docker Compose YAML file we're going to edit. So look at the file. You're going to see a section that looks like this. So you're going to replace everything like this with what you have, with everything here. Okay, remember that what you have here is a 32-bit character encryption key that you created. You just replace it with the right one you have, and then save with Control O and then exit. Then you can force to recreate your Kibana container with the new environment by simply running this command. So once the boot, of course, going to reboot your Kibana container very well for you. So if there are no fatal errors, if the Kibana open after rebooting, then go to your terminal and paste this command and run. And then you reload your Kibana on the web browser, or refresh or drop this on a new tab, and then release for you. So once that is done, then step 2 is to configure the row parameters. Where you see row name, put this. Where you see query KQL, put this tag. Where you see threshold, put 0 hits. Where you see time window, put 5 minutes. Where you see check every, put 1 minute. Step 3 is to add action. So when you see, you go to, you see add actor, connector rather, and then you point to index. Where you see connector name, put security alert. Where you see index name, put security dash alert, and then save. Step B is to create a field login threshold alert. You have to create threshold for every alert you want to. I want to log, for instance, field login alert, failed attempt, success, and maybe file access or whatever. So you see where you see file name or row name, put excessive login fails, because you have to put a name that descriptive that aligns with what you want to log. And then where you see query, put that's query log level, put this warning and tags. Where you see threshold greater than 5 hits, time window 5, and then then it's safe. Then once you create a command, and when that passive, you have to create a command injection alert. The same thing, just different entries. So when you see row name, let it be command injection attempt, detected, SQL the time, and that. So in part D is where you create your triggers and verify your alerts. So you have to run that simulation from trigger alerts. So, but what you do is run this command on your terminal. It's going to rerun the attack simulations on trigger for you automatically without you having to create the alerts yourself. So for command injection, run this on terminal. That's going to be create for you. After that is done, you need to update your logs by pasting this on your terminal and then checking the status of the Kibana alert you created. You go to management, staff management, rules and connectors, view alert history. You see that alerts may take, you see a note that says alert may take up to 2 minutes to trigger. All right. And then part A here is to perform real-time monitoring on the dashboard. You've configured your dashboard. So to watch what has happened, just drop this command on your terminal and it reveals what log has been captured. And then for it to view the throughput on your terminal, just drop this. So in part 5 is where we do incident response, look at the incident response procedures, where you have to practice containment, eradication, and recovery steps for any simulated active attack. So part A of this is for detection and initial assessment. So to do that is you can list your running containers and the IP addresses. So by running this command, that reveals the 6 containers that we're dealing with and the respective IP addresses. That's for containment. Or you can inspect a specific container by just running this. Right, that reveals specific containers for you. And then step 4 is for here, you have to block the attacking IP address. You've identified the IP address of the attacker. So first of all, you need to look at the IP address table. And then, so for instance, this is the IP address of my attacking machine. So just say IP equals this or the script, and then I run this command. It goes. To verify that the rule you created was added on the IP table, run this sudo command, and then you can actually optionally pause the attacker container if you want. If you discover that an attack is coming from a particular machine, you can just pause it by running this command. And then for preservation of evidence, you want to move the evidence from whatever directory that is found to where you want to move it to. So you run this command, first of all, to make a directory where you want to move the incident. You want to copy the incident file to, and then you run this command. It's going to copy that to save for you. Okay. So we run after this command, we run this so they can copy the log file for you. For you to export manually, you go to Kibana in your web browser, go to Discover, and then you click on Share. From Share, select CSV report. It's going to export the log file to whatever directory that is specified. For you to save the container file system snapshot, so first command is going to save the snapshot as a .tar file for you, for they can view later. Then you can also create MD5 hashes for your evidence integrity for that particular file, so that there will be no case of mutilation or changes or modification. This is simply done by doing this. And then part D is eradication, where you have to remove the malicious IP addresses from the IP table. So you specify the IP address of the attacking machine here, and then run this command. It's going to send out that machine that is causing the attack on the network. Once that is done, move to step 9, where you have to start the application container in a clean state. So first of all, you have to stop and remove the app container. So run this compile stop, and then run this compose remove, and then you refresh your application. You verify your application is running fine. Then here you move to recovery and validation. You have to verify the application is accessible. So when you run this command on your terminal, the expected result is supposed to be 200. So if it returns 200, it means the application is clean, it's fine now. Then you can confirm that the attacks are no longer successful. Okay, so to do that, just run this to see if it can break into the system. This is SQL injection. So if this fails, it means that the attacker can no longer have access to the system. All right. So once you run this, the response should be 200. Then findings and reporting. When you're done with this, you're supposed to have a report. So there's a sample table where it has attack type, what attack type was simulated, detection rate, what rate was that, the alert created, that they're working, yes or no, and then the coverage gap, we identify that. So, and then I've talked about improvement recommendations. You recommend improvement based on what has been discovered on the system, either immediate fixes needed, or short-term, medium-term, long-term. I've also talked about the compliance alignment summary, where we have to comply. You have to see whether what you've done complies with the ISO 2700, the NIST cybersecurity framework, or the PCI DSS framework. So that's that about Module 5. I hope you've had a good time. So take your time to go through all the scripts, all the commands provided in the scripts, and execute them, and then make your findings, and then report and get back. Thank you for staying with me. Bye for now. See you in the last module, Module 6.